Okay, fifth graders, today we're doing Module 3, Lesson 12, and we're working on subtracting fractions that are greater than or equal to 1. So what that means is the second fraction, the one that you're subtracting from another number, is going to be greater than or equal to 1, which means it's going to be a mixed number. First, let's talk about the problem of the day. You should have already done the problem of the day with your sub, but if not, please pause the video so that you can make sure you write down the important information, what the question's asking, you should write that first, and then show how you know. Please pause the video now so that you can do all that and solve it before you check your answer against mine. Okay, so the question's asking us to figure out how many more pages Max needs to read. We know altogether he has 15 and a half pages to read, and he read 4 1/3 before taking a break. So in picture form, remember you always need to RDW, read, draw, and write. Altogether he has 15 and a half pages. He's read 4 1/3 pages. So the rest is what he still needs to read. So what we need to do is 15 and a half minus 4 1/3. However, we don't have like units. So we can take our fractions and rewrite them using equivalent fractions that do have like units. We can see that 1/2 is equivalent to 3/6 and 1/3 is equivalent to 2/6. Therefore, we can rewrite our problem as 15 3/6 minus 4 2/6 to get 11 1/6 pages left. Okay. Let's take a look at these equations for a second. We have 1 1/2 minus 1/5, and then we have 1 1/5 minus 1/2. What's different about them? Well, what's different, obviously, is that the fractions are swapped. In the first equation, we're subtracting 1/5, but in the second equation, we are subtracting 1/2. Let's model these two equations on number lines for a second. Okay, so in this case, here's 0, here's 1, here's 2. We're starting at 1 1/2 there. We're taking away 1/5, so we end up there. Okay. In the second case, here's again 0, 1, and 2. This time we're starting at 1 1/5, which is about there. We're taking away 1/2, which would put us somewhere here. So clearly, if our answer in the first case is going to be greater than 1, right? When it's here, it's greater than 1. And in the second case, it's less than 1. This reminds us that we cannot use the commutative property when we are dealing with subtraction. There is no such thing as the commutative property of subtraction. We can't just move the fractions to any place because it will affect the overall value. I want us to think for a little bit about subtraction. If I have 10 and I take away 5, I end up with 5, right? Let's say I don't start with 10. Let's say I start out with 1/2 more than 10. If I start out with more of something, but I take away the same amount, in this case I'm taking away 5, I'm going to end up with more. Instead of ending up with just 5, I'm going to end up with 1/2 because I start out with an extra half to begin with. Does that make sense? Similarly, if I have 1 and I take away 1/2, I'm going to end up with 1/2, right? But let's say I don't start with 1/2. Let's say I start with 1 and like 2/3 or something. And then I still take away the same amount. I still take away 1/2. Will I end up with 1/2 or more than 1/2? I'll end up with more than 1/2 because I have that extra bit that I started out with, which in this case was 2/3. So to find the answer, I could add 2/3 to the end. Right now, I want you to write these number sentences down in your math notebook and then pause the video so that you can write one sentence explaining what the logic is behind what we did down here. With that in mind, there are two different methods we can use when we are subtracting whole numbers, when we are subtracting mixed numbers or fractions greater than 1. In this case, we are subtracting 1 3/4 minus 6/7. Well, there's two methods. In one method, I could ignore the fraction here, the 3/4. I could just say I have 1 minus 6/7, and then I can add that extra bit afterwards. I sometimes like this method. I find it easier because, check this out, okay? So I have 1 minus 6/7. Well, I know that 1 minus 6/7 is the same as 7/7 minus 6/7, right? Which is 1/7. And then I can do 1/7 plus 3/4. All I have to do is use my LCD, which is going to be 28, right, to make equivalent fractions. I can say that 1/7 is equivalent to 4/28 because I multiplied by 4 over 4. And I can say that 3/4 is equivalent to 21 because I multiplied 21/28 because I multiplied by 7 over 7. So I can do, instead of 1/7, I can write 4/28, and I can add 21 28ths to it to get a total of 25 28ths as my answer. Sorry, my 5 looks a little wonky. Okay, so in this case, we ignored the original fraction of 3/4, the fraction part, and just did 1 minus 6/7. But then I knew that my final answer would be bigger than 1/7 because I started out with more than 1. I started with 3/4 more than 1, so my answer is going to be 3/4 bigger than 1/7. So I did 3/4 plus 1/7 to get my final answer. Okay, now method 2 sometimes is easier too for some people. Okay, and it kind of changes depending on how the problem is set up. What you could do for method 2 is convert it into an improper fraction. I know that 1 is the same as 4/4, so I can think of this as 7/4 minus 6/7. Again, I have to do the same work of using the LCD, which is still 28, right? And I can convert and write and use equivalent fractions. Let me make myself a little bit more space, okay? So I can say that 7/4 is equivalent to 49 28ths because I multiply 7/4 by 7/7. Then I have 6/7. I can say that that's equal to 24 28ths because I multiplied 6/7 by 4/4. Now I can rewrite the problem. I'm going to come up to the top so I have more space. I can say now this is 49 28ths minus 24 28ths. 49 minus 24 is 25 28ths. So you can see that I get the same answer. In the first method, I take away the fraction part and add it back later. In the second method, I convert to an improper fraction and then subtract. Different people like different methods, and sometimes one method works really well for one problem, but the other method works even better for the second problem. So you kind of have to know both ways. So for today's lesson, we're going to be practicing both methods. Okay, let's give this problem a try. 3 1/4 minus 2 1/2. For the first method, we're going to ignore the fraction part. We're going to say it's 3 minus 2 1/2. Well, I know this in my head because if I have 3 and I take away 2 1/2, I'm left with 1/2. But my answer is not going to be 1/2. It's going to be bigger because I didn't actually just start with 3. I actually started with 3 1/4, which is 1/4 bigger than 3. So what that means is my final answer is going to be 1/4 bigger than 1/2. I can use equivalent fractions. In this case, it's very nice because I know that 2/4 is equivalent to 1/2, and so my final answer actually is 3/4. This concept is really important for you to understand. In your notebooks right now, I want you to pause the video and explain why we had to add 1/4 to 1/2. Why are we adding if it's subtraction? Go ahead and pause the video and write an explanation to make sure you understand this. Okay, now let's try method 2. Remember for method 2, we are going to make improper fractions, okay? So we have 3 1/4. I know that 4/4 is equal to 1. So to get 3, we have to do 1 plus 1 plus 1, or 4/4 plus 4/4 plus 4/4. That's 12/4 plus 1 more fourth, right? So this is equal to 13/4. Our second problem, or second number, is also a mixed number, 2 1/2. We also have to make improper fractions. We know that in this case, 1 whole is 2 halves, right? So we have 2 wholes, 1 plus 1, or 2 halves plus 2 halves, plus 1 more half. So we're taking away 5 halves. So our problem really is 13/4 minus 5 halves. Well, I know that 5 halves is the same as 10/4 because I can multiply it by 2/2. So I can do 13/4 minus 10/4. And would you look at that? What is our answer? I'm going to write it up at the top. 13 minus 10 is 3. So my answer is 3/4. Again, we get the same answer using method 1 and method 2. For this question, I want to challenge you to solve it using method 1 and method 2 before you unpause the video to check your work against mine. Remember, I'm not here to see if you're really doing it or not. You could just be copying my math notes, but that's not going to help your learning. So take control of your learning and pause the video now, solve it using method 1 and method 2, and then check your work against mine. Go. So now that you've done it using method 1 and method 2, you can see that we get the same answer of 5/6. Personally, I prefer method 1 because I don't like working with big numbers. I find that when I have to convert mixed numbers into improper fractions, the numbers get really big. And when I work with big numbers, it's easier for me to make a silly mistake. However, it's important for you to know how to do both methods so that you can pick the one that works best for you. Okay, today please do the following problems in your lesson 12 problem set. Then you'll do the exit ticket. And then when you're done with the exit ticket, please turn it in and work on Zern. Thanks.